Good day to all the lecturer and friends. Today we are from Group 2 JKR Building Block B, presenting the final presentation for this project. Our group member consists of Jianmin, Ziqing, VANGHAU, FAIZATUL, ALFEQ, and Yiqing. Our presentation flow consists of 7 parts. First, from executive summary, next, literature review, case study background, energy audit, sustainable energy assessment by using PSJKR, energy simulation, and lastly, sustainable proposal. Next.
For the introduction, the building must need to be evaluated in order to achieve a certain level where the building can be able to provide satisfaction, comfort, and safety to occupants and users on the high level. For the objective of this project is to study the characteristic of energy consumption in selected building, and the aim is providing a first indication on how well the building are performing, in particular to identify any wastage of energy and identify any scope for improvement to building simulation. Next. The process of this conducting this task is literature review, case study, analysis and finding, and conclusion and recommendation. The significance of study is to focus on energy consumption of chosen case study building, which is Block B of Complex Jabatan Kerja Raya, and any information on the use of electricity and features that involve in energy performance on the building will be evaluated and analyzed in order to ensure that each item can provide comfort to residents and users. There are certain limitations that have been faced in completing this project due to COVID-19. A face-to-face meeting with the JKR building management and observation on the building cannot be done due to movement control order. Any information and data regarding to the building is obtained from the building management, and each discussion among the group is conducted virtually.
For literature review, the energy consumption in Malaysia, the consumption energy show the increase from year 2010 and 2019, which is from 118 terawatt hour to 162 terawatt hour.
The low level of funding and poor maintenance of building energy system are the challenges, as they may result in degraded energy performance. There might be a performance gap between the design and actual energy performance of building. To solve this, post-occupancy assessment can help to close the gap, as the design team will better understand occupant feedbacks.
So what is energy efficiency? It's a reduced energy use to perform an activity which to avoid energy waste, and energy efficiency usually can be improved to building design, renewable energy, and also choosing energy efficiency electrical appliances. Energy efficiency help in reducing greenhouse gas emissions, which reduce pollution to environment and protect the earth.
Literature review is included to provide a general understanding and knowledge of electricity energy consumption, which include HVAC system, lighting system, electrical equipment, and plug loads. Next.
Okay, so for background case study, our case study is Block B JKR Malaysia, located at Kuala Lumpur, and the type of the building is office building, and the number of story is 4 story. The net floor area of this building is 2,150 meters square. The air conditioning area is 1,652 meters square. The operation hour is Monday to Friday, 7:30 AM to 6 PM, and the number of occupant is 11. So the overview of the Block B building consists of 4 story, which is ground floor is examination board. Level 1 is corporate management branch communication division. Level 2 is corporate communication division, and level 3 is road branch center project management division.
So for the environmental aspect, the first part is the building orientation. So the left of the building of the Block B JKL building is the east, and the right of the building is the west. Next. So for the sun path, the sun rise on the left of the building and set on the right of the building through the back of the JKL Block B. Since the direction of the sun is through the back of the building, so the back of the building receives the most sunlight. So for the average annual temperature, the average annual temperature is 29 degrees Celsius, and the lowest temperature is 25 degrees Celsius, and while the highest temperature is 33 degrees Celsius. For the wind direction and the airflow, so the wind direction comes primarily from the southwest of the building to the northeast, while the wind speed varies occasionally. For the humidity, it is hot throughout the years. The annual average humidity percentage is 80.5%. From the figure, the most of the humid is December, while the least of the humid is July. Next.
For energy consumptions in IPJKR, the energy consumption in 2020 is 3,167,971 kilowatt hour. So compared to year 2019, 2011 and 2020, the energy consumption showed a decrease of 37% due to the installations of energy management system, which is implemented since 2014. So this is the energy distributions in IPJKR. So most of the energy used is for the HVAC system and followed by the indoor lighting.
Next, I will be presenting about the energy audit for JKR Building Block B in 2020. So what is energy audit? Energy audit is a process to identify energy use among the various services and to identify the opportunity for energy conservation. The ultimate objective is to reduce the energy consumption without compromising the comfort and the quality of the building. And the diagram at the left shows the process of energy audit, which are the first step data collection, next desktop data collection, field data collection, cross-checking of load demand data, end-use load apportioning, analysis and identification of energy conservation measure, and lastly, reporting. So the energy audit for MVAC system. There are two types of MVAC system in Block B JKR, which are centralized system and split unit system. The figure at the right shows the total kilowatt hour consumed by the MVAC system, which are 47,895.01 kilowatt hour. The highest energy use of aircon is on January, while the lowest energy use for aircon is on April. Overall, the MVAC system consumes 40% of overall energy consumption. And this is the specification for MVAC system for centralized system. There are cooling tower, water cool package unit, and exhaust fan. And this is the energy audit for MVAC system for split unit. There are 22 pieces of split unit in JKR Block B, where there are 2 units of cassette type and 20 units of wall type.
In Block B of the JKR building, there are 3 different types of lightings: fluorescent light, halogen, and PLC lamps. Total watt of each fitting in Block B is summarized in the table. The total number of working days is 212. Total energy consumption of lighting system is 23,632.5 kilowatt hour in 2020.
So for the energy audit for others equipment, the first one is the desktop. There are 57 units. For the printer, there are 35 units. For the photostat machine, there are 5 units. Stand fan, there are 8 units. So for the water dispenser, there are 2 units. The ice block is 3 units. And the last one, the microwave is 1 unit. Next. So for the total energy consumption for the equipment in Block B is 627,750 watts. Next.
So energy audit for overall system in Block B, energy consumption by system in 2020. So for the MVAP system, it is a 40% and the lighting is 20% and the other equipment is 40%.
For energy consumption in Block B building comparing year 2019 and 2020, the total energy consumption in 2019 is 134,870 kilowatt hour. For 2020 is 119,303 kilowatt hour. So in 2020, from March to May, there is a huge decrease in energy consumption due to the implementations of MCO. Next. So this is the building energy index using the formula. So for the BI on 2020 is 55.87 kilowatt hour per meter square per year. For BI for 2019 is 63.16 kilowatt hour per meter square per year. Next. So the diagram show comparing the BI of IPJKR Block B with the standards such as the MS1525, GBI, and PSJKR, and so on. So according to our finding, BAI fulfill all the standards. For sustainable assessments using PSJKR, PSJKR was developed by PWD and is a measurement tool to assess the sustainability level of government development project and to promote the requirement in sustainable development. So there are 7 main criteria, but in our project, we only focus on KT, which is the energy efficiency. Next.
So for the KT1 roof design, the requirement is a U value for whole layer of the roofing material needs to obtain for heavy roof 50 per kilo per meter square is less than 0.6 watt per meter square. So the marking for this is 0.54229375 meter square per watt. So this is fulfill the requirement. So it's given 2 mark for this KT1. Next. For the KT 2.1, the main feature of the building facing north south orientation. So the requirement is the reduced direct entrance of sunlight into buildings with more facing the south north. So there is no window in the east or the west. So it's fulfill the requirement is given 1 mark for KT 2.1. Next. So for the KT2x2, the minimum openings on east and west facing faded. So the requirement is ensure WWR is less than 40% in the east and the west. So the marking here is show the WWR for each of the direction. So there is no window in the east and the west. Therefore, the WWR in the east and the west is less than 40%. If fulfill the requirement is given 1 mark for the KT2x2. Next, so the plan will show there is no window in the east and the west. Next.
KT 3.1 is about the U value of external wall and should be comply with the requirement of MS1525. 0 marks will be given for this part as it does not comply with the standard. Next. KT 3.2 is about shading device and the requirement of PHJKR is to have horizontal shading on east and west facades. However, Block B does not comply with the requirement, so 0 mark will be given. Next. KT4 is about OTTV, of which should be less than 50 watt per meter square. The OTTV of Block B is 68.94. However, it will not be given marks as it is not applicable in our building. Next. KT 5.1 and 5.2 require lighting plan to give marks. As there is no relevant document, no mark will be given in this part. Next. KT 5.3 is about lighting power density and it must comply with the value specified in MS1525. Maximum LPD value for general office is 12, and it is found out that only 46% of the space in Block B did not meet the requirement. Therefore, 0 mark will be given. Next.
For KT 6.1 coefficient of performance, the coefficient of performance need to according to MS1525, and I found that 9 units out of 22 units of air conditions, their COP does not meet the requirement, which is 2.93. And for KT 6.2, green refrigerants, so the requirement is to have a refrigerant according to the needs of ozone depletion potential and global warming potential. And I found that all the air conditioning using R410 air refrigerant, which comply, and 1 mark will be given for this. Next. For KT7, 0 mark will be given as there are no relevant documents such as the air conditioner plan and mechanical plans for the building. Next. For KT8, 1 mark will be given out of 6 marks as there's only 0.44% of the renewable energy in the building, which less than 1%, but there are a solar panel on the building, so 1 mark will be given for this. Next. For KT9, the energy performance, 10 mark will be given out of 10 marks as through the calculation, there's more than 50% of reduction of energy consumption.
For KT 10.1, installation of submeter digital, the building has installed the submeter for ACMV, lightning and socket on 2017. So 5 marks are given. For KT 10.2, energy control management system, the building is using building energy management system. So 5 marks are given. Next. KT 10.3, verification of display and control system, 0 mark are given because there are no relevant document. Also, lastly, KT 11, testing and commissioning, there are also no relevant document on preparing testing report and record of testing for system. So there are no mark are given. Total mark of KT obtained by JKR Block B are 26% over 50%.
So for 6.0 energy simulation, so for our case study, we have used a Equest software to get a data simulation energy of Block B building. So Equest is energy modeling simulation tools developed in North America, and Equest allow for complete building performance analysis. It evaluate the energy use performance in building. So in Equest include DOE 2 engine, which are schematic design wizard, design development wizard, and energy efficiency wizard. So after building described is compiled, Equest produce a detailed simulation of building as well as estimate of how much energy is used. So this is our 3D modeling of JKR Block B. So generate information of the model JKR Block B. Building types is office building, might rise, and with the file is Kuala Lumpur. Analysis year is 2020. First season is 1 January until 70 March and continue 31 May until 31 December. So season 2, second season is 18 March until 30 May, which is during MCO. So this is generate information of model for building material specification, and for the MVAC system specification, there is a 2 system of MVAC system, which is a chiller water coil and DX coil.
So this is a comparison between the actual energy breakdown and the simulated energy breakdown. The pie chart on the left shows the actual energy breakdown where the information is obtained from the Excel, and the simulated energy breakdown is simulated by using Equest. From the table below, we can see that the differences between the actual energy end use opportunity of MVAC is 10%, lighting is 2%, other equipment is 8%. This is the breakdown of simulated energy as captured from the request and simulated monthly electrical consumption for 2020. The chart shows the monthly breakdown of electrical consumption, where the most of the electric consumption is by the MVAC system as shown in blue, and the second most electrical consumption is consumed by the other equipment, and least electrical consumption is consumed by the lighting. This table shows the monthly electric consumption by each system in figures, and the monthly electrical consumption range from 9,000 kilowatt hour until 16,000 kilowatt hour, and the total electrical consumption is 166.82 kilowatt hour per year. This is the comparison between the actual energy consumption and simulated energy consumption. The differences between the actual and the simulated data are 47.51 kilowatt hour per year. The differences in data are due to the following reason. The first is due to the MCO in March until May. Government start to implement MCO throughout Malaysia and staff in JKR are required to work from home. Secondly, incomplete data obtained. There are assumptions made as there are lacking of information from the data set. Thirdly, unable to conduct site visit. Inspection are unable to be carried out due to the rising number of cases. And lastly, limitation of imputing data in request. Some of the specifications are set on default in request. This might not fully represent the actual specification of the case study building. The analysis of low energy consumption between March until May is due to the reason of MCO, and to ensure the accuracy of the simulated data, during the MCO period, which is March until May, we set it as the second season in request. By second season, it means that the light loads and the equipment loads are set way below than the normal rate, but the system is not completely turned off in order to prevent the system to break down.
So for the sustainable proposal, next. So for the low scope proposal, the first one is the temperature control. So the thermostat can improve the perceived thermal comfort. The next is the automatic control filled with the off-power control air conditioner system, which can minimize the energy consumption. Next.
Create awareness of building users on energy saving. By create campaign to raise awareness on energy saving in building and provide poster that provide all information or data on energy use in occupied building can raise awareness on energy saving. Okay, next.
So regular maintenance of system. So it must be done to produce energy saving of the building system, such as replacing HAIQAL filter and washing window for make sure the system work properly. Next. So for encouraging the use of natural lighting, so during daylight we can reduce around 10% of the energy. So not only lighting in interior space can be optimized by using natural lighting, but warm as well.
The switch off equipment when not in use. Electrical appliance will require the use of electricity through a socket or electrical connection. Every electric appliance has a standby mode that always works when not in use. And by pressing warning sign on every socket to give awareness to users to turn off the switch after the using the equipment can reduce the energy consumption. Okay, next.
For the medium cost proposal, 24-watt LED tubes will be installed to replace fluorescent tubes as they save more energy and reduce more cost. The total cost for the proposed installation is 3,570 ringgit. The ROI for this proposal is 1.5% with a payback period of 8 months. Next.
For the HAIQAL proposal, the Panasonic 2.5 HP standard inverter air conditioner with a 5-star rating energy efficiency and using R22 refrigerant will be chosen. Next. The total installation cost is 37,710 ringgit, and for the ROI is 15.9%. For the payback period is 7.5 months. That's all from us. Thank you so much.